Good morning, Year 7. Here we are, Lesson 12 of Elements, Mixtures and Compounds. And today we're going to be focusing on compounds and mixtures. And we're going to learn that mixtures can be easily separated. So if you mix something together again, then it's quite easy to separate it. So let's have a look and remember back to those three definitions that are really, really important. An element is made up of one type of atom. A compound is made up of two or more different types of atom, and they're joined by a chemical bond. And a mixture contains two or more substances mixed together, but they haven't got a bond. There's no chemical bond because they haven't reacted together. And this is why you can separate a mixture. Because there hasn't been a chemical reaction, because those bonds haven't formed, they're really easy to separate. Once you have a chemical reaction and bonds form, it becomes more difficult to separate the elements out. So we can think of these in diagrams. We're going to be doing more of this in the next lesson. Hang on a second, I'm just going to move the camera a little bit so you can see everything. There we go. Okay, so if we had a picture of elements and we were using particle diagrams like you did way back at the beginning of Year 7, okay, this diagram here, using the particle diagram, you can see this is an element, and you know that because all the balls are the same colour. And here we've got these two balls joined together. It's actually an oxygen molecule, because remember, oxygen has got two atoms. An oxygen molecule has two atoms and they're joined together. O2, you've seen that sign everywhere, haven't you, with the mobile phone network? So O2, this is an element of oxygen. This picture here, this shows a compound, and we know that because the two balls are different colours, so that tells us that they're not the same atoms, and also they're stuck together, so there's a bond there. Okay, so this is a compound. And if we look at the last one here, okay, this is a mixture. And we know that because we can identify this little fella here as a compound because there's two different colour balls stuck together. This is actually water, H2O. Okay. And then this, we know this is an element because there's only one ball there. So this box here is a mixture of elements and compounds. Okay, so little bit more about mixtures and compounds. Sorry, I haven't translated that here, so here's a learning point. Cyfansoddion is compounds in Welsh, and cymysgeddau is mixtures in Welsh. Okay, so compounds and mixtures. So I'm just going to play this video. This is another teacher, and she is talking about the difference between elements, mixtures and compounds, and she's using two elements to do this. She's using the element iron and the element sulfur. Okay, so I'm going to stay here, play the video, and she's going to tell you all about iron and sulfur.
Hi Year 8, this lesson we're looking at an example of elements, mixtures and compounds. So I've got some iron represented by the black mollymods. Okay, so that's my element of iron, and I've got some red mollymods to represent sulfur. Okay, so iron is a metal, so there's fine iron filings there, and sulfur is a non-metal, and it's this yellow powder. So if I took some sulfur and I mixed it with the iron to give us a mixture of iron and sulfur, okay, would it be possible to separate the iron from the sulfur? And if so, what method could we use? Okay, so the simplest thing to do would be to use a magnet. So I can take a bar magnet and I can wave that over the iron and sulfur mixture, and the bar magnet will attract the iron and separate it from the sulfur. So because iron and sulfur have just been mixed together, it's quite easy to separate out, okay, the iron from the sulfur. Right, so if we look at the mollymods, all we've really done is got the iron and the sulfur to mix together, and they're not chemically joined in any way, which means it's quite simple to separate them. Okay, so what could we do to make the iron and sulfur chemically joined together? So to get a chemical reaction to happen between iron and sulfur, what would I need to do? Right, so that's my second experiment. So here I've got iron and sulfur in a boiling tube, and I'm heating it strongly. So by heating the iron and sulfur, I'm causing a chemical reaction to happen, and that's going to make iron sulfide, and that's my compound. Okay, so there's some sulfur, just a little bit of sulfur left around the boiling tube. Okay, and it's starting to heat up, and it should start to make some iron sulfide. And I've got some that I produced earlier. So here's some iron sulfide at the bottom of this boiling tube, and if I get some of this out, okay, we can see that we've now got iron sulfide. Okay, so that's iron sulfide. It looks nothing like the iron and sulfur mixture. Okay, and if we try to separate the iron from the sulfur, that's not really going to happen. So even if we use a bar magnet, because they're chemically joined together now, and we've now got a compound of iron sulfide, it's not possible to separate the iron from the sulfur. Okay, so we've gone from an element of iron and sulfur to a mixture of iron and sulfur, and now a compound of iron sulfide.
Okay, so elements, mixtures and compounds. What we're going to concentrate on for the next few slides is how we separate mixtures. And that's one method that you've just seen there, using a magnet. If one of the things in the mixture, if one of the substances in the mixture is magnetic, we can separate it using a magnet. Okay? And there's lots and lots of different mixtures. You can see a few here. So we've got Smarties, we've got a cup of tea, spag bol, mixed nuts, orange juice. Over this side, we've got some more chemistry-like ones: salt and water, sugar and salt, ethanol, which is alcohol in water, air. The air that you breathe is a mixture. Okay, so there's lots and lots of mixtures. When we're talking about mixtures, we can be talking about things that you find in the kitchen, but also we're talking about things that you find in the chemistry lab or all around us. And the most important thing about mixtures is, like the lady in the video showed you, you can separate a mixture, and you can separate it quite easily. So let's have a look at some different mixtures and how we might separate them. So if you've got two solids and one is slightly bigger than the other solid, then you can separate it out just using a sieve. You've probably done this in the kitchen. If we had a mixture of sand and gravel in the lab, then we could quite easily separate it out, because the gravel is big and it'll get trapped in the sieve up here, and the sand is small, so it will be able to pass through the sieve and we can collect it at the bottom. Easy, no problem at all. Okay, what if we had sand and water? We couldn't use a sieve this time, because using a sieve, if we use the sieve, the water would just go through it as well as the sand. Okay, so we'd have to have a different method, and this gentleman with the fabulous lab coat is going to tell you about that now.
The fastest way to separate this mixture of water and sand is to use a paper filter. Filters allow us to separate water from insoluble substances, and this sand is insoluble. It won't dissolve in the water. So when I pour this mixture through the filter, the sand is caught by the filter, but the water just goes right through. I'm sure this is a solution that you and your classmates came up with. Keep up the great work. I'll see you next time.
Okay, so using a couple of words that he used there, he used the words soluble and dissolve. Okay, so if a subsolid is soluble, it means it will dissolve. And you can tell if something is going to dissolve by putting it in water and stirring it. So if you were to put sand in water and stir it, you could stir it all day long and you would still see the grains of sand in the water, because it's insoluble, it can't dissolve. So anything that's insoluble, we can separate from a liquid just using filter paper and a filter funnel. But what if this solid is soluble? What if it can dissolve in water? For example, sugar or salt. If you put sugar or salt in water and you stir it, then the sugar will dissolve, or the salt will dissolve, and you'll end up with just a clear liquid. Okay, sugar hasn't disappeared, hasn't gone anywhere, it's in there, but it's dissolved, so we can't see it anymore. Okay, so we obviously can't use the filter paper, because the filter paper, the sugar in the water or the salt in the water is just going to go straight through the filter paper, so we're not going to be able to separate it that way. So this video is showing you how you would do that. I'm just going to talk across the top of this one. Okay, so if we were in the lab doing that, this experiment, the first thing that we would do is we would make our solution of salt and water. So we would put our salt into a beaker and we would stir it until we got a clear solution. Okay, and that's what this little lad is doing here. Okay, he's going to stir it until he gets a clear solution, and then once he's done that, he's going to put it into an evaporating basin. Now this should give you a clue about how this process works, because we use evaporating basins to evaporate things. Now, if you remember back to matter when we did changes of state, evaporation is when a liquid turns into a gas. And that's what we're using here. We're using the fact that if we heat this water up, it will evaporate. So using the Bunsen burner to heat the solution in the evaporating basin, the water is going to heat up, it's going to evaporate, turn into gas, and then it's just going to float away. And what we're going to be left with at the end is all the salt crystals. Okay, so all these salt crystals are left behind, the water has evaporated off, so we have managed to separate that mixture, which is fine. Okay, that works pretty well if you want salt. What we do, okay, if you just want to get the salt out of the liquid, as you can see in the picture here, to separate a mixture of a solid that has dissolved, that is soluble, we heat it until the water evaporates and the solid is left behind. Okay, but sometimes in chemistry, we don't want to lose the liquid. In this particular method, the water evaporates off and we lose it. What if we want to keep the liquid? What if the liquid is useful to us? Okay. Then we use this nifty little bit of kit. Okay, this is called a Liebig condenser, this whole thing here. Okay, I'm not going to play this video. This was just a picture that I found. Now, if you have a close look at this, you can see that we've got a Bunsen burner and we've got our salt and water solution in this flask here. Okay, so the first step of this process, this method, is evaporation. We are going to heat the salt and water solution until the water starts to evaporate. The water turns from a liquid into a gas, and then that gas, that steam, is going to rise. Now we've got a bung at the top here, and that's quite important, so the steam can't escape. Okay, now remember, when things get warm, they rise up, okay, because they become less dense, so they rise up, so the steam can't go back down again. It's got nowhere to go apart from down this side arm here. This is another flask. And what we have here is a glass tube going through a flask full of cold water. Okay, so what happens when this steam is forced down here? Remember, when a gas cools, it condenses, it changes from a gas into a liquid. So when we run cold water around the tube that the gas is in here, it's going to condense, it's going to change from a liquid, from a gas back into a liquid, and then we can collect it in the water. So with this technique, using the Liebig condenser, it's called Liebig because it's the man who invented it was called Liebig, and condenser because obviously you're condensing the water vapor or the steam. So we've got, when this whole process is finished, we've got the salt in the flask and the water in the beaker. So we've kept both parts of the solution with both parts of the mixture. Okay, so now you're going to complete the quiz. Just a little warning here. In the quiz, you are going to be asked to name some bits of apparatus. Do you remember way back at the beginning of year 7, we did this and we played bingo quite a lot to get you to recognise all the different bits of equipment. Well, this is a bit of a revision test, so we'll see how many of those you remember. Okie dokie, good luck, and I will speak to you in a couple of days, guys. Ta-ra!